All right, guys, welcome to this page of the notes. And what we're going to do here is we're going to take a look at the last possibility when it comes to the quadratic formula and the possible types of solutions that you could wind up with. And as you can clearly see, it's imaginary. Again, like I said, when we talked about imaginary numbers in section 4, I hope you didn't think that that'd be the only time that we would see them. They're going to keep coming back. So I'm going to write it all out for you this time, but at this point you should be pretty comfortable with imaginary numbers, and that's what we're going to wind up with, complex solutions or imaginary numbers. So real quick, before we get started, just as a reminder, remember that I is equal to the square root of a -1, and I squared is equal to -1. Now let's go ahead and jump right into these. I need this to be in standard form, so add the 10 to the other side. And it's going to be an ax squared plus bx plus c is equal to 0, where a is equal to 1, b is -6, and c is 10. And once again, plug and chug. All right, so here's what we got. We got a -6 divided by 2 plus or minus. All right, so here's what I got. I got a -6, which I'm going to square, and then I'm going to have a -4 times 1 times 10, all divided by 2, which is going to wind up being negative times a negative is going to be a +6 divided by 2 would be a +3, plus or minus. 6 squared is going to be 36. So -40. Oh, look at that. Here's what we wind up with. You wind up with a -4 under the radical. So I'm going to be taking the square root of a -4 all divided by 2. And hopefully now you quickly see, okay, that's why it's going to be a complex solution, taking the square root of a negative number. Well, here's how we deal with that. Remember what we did in section 4 was we rewrote that guy using the multiplication property of radicals, the multiplication property. I can rewrite it as 4 times a -1. And the product property says split them up. Square root of 4 times the square root of a -1 all divided by 2, which means x is equal to 3 plus or minus. Now, the square root of 4 is 2. And the square root of a -1, remember I wrote it for you up there at the top, it's an I, and it's all divided by 2, and oh, look at that. 2's cancel each other out, and you are left with x equals 3 plus or minus I. So your two solutions are x equals 3 plus I, and x equals 3 minus I. And that went so well, we should try another. There we go. I need it to be in standard form, and it is. A is equal to 3. Plug and chug. All right, so here's what we wind up with. 5 squared is obviously 25. -4 times 3 times 4 is going to be a -48, all divided by 6, which means you wind up with a -56 plus or minus the square root of 23. I'm sorry, the square root of a -23. Which is definitely going to be imaginary. No, 23, I can't split it up, so actually we're going to pull out, just pull out the I, that's all you can do. So we have -5, 6 plus or minus the square root of 23, which is an irrational number, divided by 6i. Those are your solutions. Minus 5, 6 plus square root 23 over 6i. Not only is it irrational, it's imaginary. And minus 5, 6 minus the square root of 23 divided by 6i. Two complex solutions. Let's try another. We need it in standard form, so let's add that 13 to the other side. Good work. And standard form is, and A is equal to 1, B negative 4, and C would be a 13. Yeah, plug and chug. And here's what we wind up with. Negative times a negative is going to be a positive 4. Positive 4 divided by 2 would just be a 2, plus or minus. All right, so a negative 4 squared is going to be a 16. And 4 times 13 would be a negative 52. 16 minus 52 is going to be a negative 36. Awesome. This one turns out to be a perfect square, but it's still negative, which means it's going to be imaginary. So we wind up with 2 plus or minus 6 halves I, right? Because the square root of 36 is 6. The square root of the negative 1 is I, and it's divided by 2, and 6 divided by 2 is 3. So your answers are x equals 2 plus or minus 3i. So you wind up with 2 plus 3i and 2 minus 3i as your two solutions. Guys, that takes care of all the problems on this page of the notes, as well as also taking care of the last of the possible situations you could run into when using the quadratic formula. So that takes care of our first objective or learning target, solving a quadratic equation using the quadratic formula. What we want to look at next on the next page of the notes is we're going to take a look at the discriminant and how we can use the discriminant to determine what kind of solutions we're going to get. So head on over to the next page of the notes. I'll meet you guys there.